But in this case, you think of your brain as having, or your mind as having these two parts, a system one and a system two. System one does the automatic things that you've learned, like when you're first learning how to tie your shoelaces, right? You have to really work at it. You might even work out a song with it that you might have had with your daughters, for
Hmm.
example. And as you learn it, it's a difficult task that you're not able to do automatically a priori. So you go through it mechanistically over time, you learn the complexity, and once you've done it enough times, it gets transferred over to system one. And once system one takes over, then when you're tying your shoe, consciously, you don't even think about it. But we do something very similar in our framework. We make these ensembles of large language models. So we don't just look at one LLM by itself. We imagine a bunch of LLMs and we divide them up. We divide them up into similar categories like this, system one and system two, but our division's a little more complex. It also builds upon the way that currently large language model, you hear about, they have billions and billions of parameters that they have to learn. But they also make smaller versions of these, which are a little less powerful. And the way they do that is they use a teacher-student distillation model, where in this case, a larger teacher helps fine-tune or teach a student LLM. And then you can release a model with just millions of parameters rather than hundreds of billions of parameters. That was our sort of initial connection through line between what's happening on the computational side and what's happening on the neuroscience side of things. System one, when it gets stuck, when whatever input from the world triggers internally that, hey, exactly what you said, what I'm doing isn't working. When that gets triggered, the mind shifts to system two thinking. And system two, which is kind of lazy, says, all right, let me get on this. I don't want to be engaged, but now that I'm engaged, let me figure out how to solve this problem correctly. And so then once it learns the correct way to solve it, it transfers that learning to system one, the larger model. Same thing we do on the LLM side in the teacher-student distillation. In this case, we have a small LLM with just a few millions of parameters, and it wants to learn how to do maybe a specific task. And so you train on this larger model with billions and billions of parameters that solves all kinds of tasks, and it helps fine-tune the smaller model to solve that problem better. And then you can run it with fewer compute resources. So it turns out the framework that we make is kind of a generalization of what people were doing there already, and it's inspired very directly by the system one, system two paradigm.